Hello friends, this problem of ln x whole square integral can be solved by using a very simple tool in calculus called integration by parts. So I'll quickly run you through the formula and then we'll learn how to solve this problem actually. So integration by parts, the formula that is supposed to be used is integral of uv with respect to dx. What are uv here? U and v here are functions of x. So they are some functions of x. So we are multiplying these two functions and we are trying to integrate the product of these two functions. So the integral of uv with respect to dx is given by u times the integral of v dx minus the integral of the derivative of u times the integral v dx. Now let us quickly understand here what is going on in this formula. We realize that in the entire formula v is always undergoing integration. So you can see here v is undergoing integration, v is again undergoing integration in this case, whereas u is never undergoing integration. U is either as such or being differentiated. So when we are using the product rule or the integration by parts, we'll be making sure that we choose that function as u which is relatively difficult to integrate, and we choose that function of v which is easier to integrate with respect to both of them. So we're using this integration by parts under this isolate rule, which decides which function is easy to integrate and which function is difficult to integrate. The isolate rule goes like this. I stands for inverse trigonometric functions. Normally these type of functions are very difficult to integrate. So in the rule isolate, we keep these functions as the number one functions and those functions are taken as u. Next is L, which is nothing but the logarithmic functions. Again, these functions are difficult to integrate and hence if they appear, they have to be taken as u. Next goes A, which is nothing but the algebraic functions. All the polynomials, all the constants, they are treated as algebraic functions. T for trigonometry. So sine, cos, tan, sec, which are easily integrable, are taken as trigonometric functions. And finally E for exponential functions like e to the power x, a to the power x, and so on and so forth. So while deciding which functions to take as u and which functions to take as v, we take the help of the isolate rule. So higher the function in this particular order, we take it as u, and the lower the function in this order, it is taken as v. So in the next section I will be telling you how to solve the ln x whole square integral. Alright friends, now let us look into this problem, integral of ln x whole square, how to solve this problem. So for this problem, as we already discussed in the previous section, that we'll be using integration by parts, whose formula I've already written for you. So integral by parts formula, IBP formula, which I'll be referring to by the abbreviation, is this formula. Now when I'm using this formula on this particular example, first of all I need to decide which function should I take as u and which function should I take as v. Now ln x whole square can be also written as ln x whole square times 1. Right? Now this is a strategic way of writing it because I cannot take ln x and ln x as two different functions and treat one as u and another as v, because then v will not be an easier one to integrate. So I need to write 1 next to ln x whole square and I'll be treating ln x as u according to the isolate rule. Isolate rule, the L comes before a. Please note 1 is treated as an algebraic function, so it will be the position of algebraic function is below the logarithmic function, so it will be treated as v, and logarithmic function will be treated as u. So according to this formula, which is u times integral v dx, so ln x whole square integral of 1 becomes x. Now minus, which is this minus, integral of the derivative of u with respect to x. Now please note here, ln x whole square, the derivative for ln x whole square will be following the chain rule, which goes like 2 times ln x into derivative of ln x with respect to x, which is 1 by x. So this becomes 2 times ln x into 1 by x, and integral of v dx, which is integral of 1, is again x. So we'll be finding the integration of this with respect to dx once again. When we simplify this expression no doubt becomes x ln x whole square minus this x and this x stands cancelled. So it is simply 2 times ln x with respect to dx. Now I'll be applying the integration by parts formula once again. Yes, once again on this particular problem. So ln x, now again I will treat it as ln x times 1. Right? And again I will treat this as u and this as v according to the Eilate principle. So 2 times, now I am starting my integration by parts under this square brackets. So u times integral of 1 is again x minus the derivative of ln x, we all know the derivative of ln x is 1 by x, times integral of 1 is again x and the integral of the whole thing with respect to dx. So this x and this x both stand cancelled once again. So ultimately I'll be left with x ln x whole square, which is nothing but a copy forward of this term, and this is 2 times x ln x minus, what is the integral of 1? Integral of 1 is x, so it becomes minus x, and let us add a constant of integration to round up this problem. So this solves your question, what is the integral of ln x whole square? Thank you so much.